let's start this part of the presentation. Gonzalo will come back on stage again and give us some insights into the use cases of the IOWN Global Forum, and then we'll transition to the panel. Please welcome Dr. Camarillo.
Thank you. Excellent. Glad you came back from the break and people can, trickle down slowly from, getting their coffee. I'm going to present very briefly what we are doing in the forum, a bit more concretely, like what activities, use cases we are focusing on, and then we will go and I will basically give the floor back to Vito or to Jeff so that he continues with the panel, which is going to be extremely interesting. So I will try to keep this short. You already know me. This is the use case approach that I already described before. Again, you remember it was highly iterative. We first start with use cases, distill requirements from there, and then the requirements, they make it to the blueprints we develop. And again, think of, deployment, basically models, integration architectures and all that. And then we validate all these assumptions and we eventually have something ready for deployment. We covered that already in the first presentation. This was just a quick refresher. What I want to focus here on is what exactly are the use cases we are focusing on. So we have two types of use cases. The first one is on the left. Here you have early adoption use cases, which are use cases that we think they could be basically deployed more quickly, and these are the ones that sometimes we call them in-focused use cases, because those are the ones we've been focusing on mostly. And then future-looking use cases, which are more, future-looking, more ambitious maybe, and the timeline is a bit more into the future. So we have two types. And there we have, I'm going to be covering just the early adoption use cases because those are the ones usually you will see associated with the forum because we've been promoting them quite a bit and they are much more advanced in our thinking, in the blueprints we have basically prepared. And then I will be covering just one future use case so that you can see what we are looking at, which would be the network digital twin in particular. We will be covering another use case in the panel. After the panel, Jeff will be moderating. We will have another panel that I will myself be moderating. And we will basically focus on the first one, the cyber physical systems, in particular the warehouse management, but that's for later. So without further ado, again, early adoption use cases, financial services, broadcast media, AI implementation, and construction. First one is financial services infrastructure. As you know, the financial services institutions, like banks, for example, they are heavily regulated. So you cannot lose transactions. That's not allowed. They work under the principle of zero data loss. So if you have a ledger with transactions, again, you should make absolute sure that this data is consistent and you cannot lose it. This leads to basically a strategy for backups, which is synchronous replication. You need to be replicating everything in real time, and then until a transaction is not stored in two different data centers, you will not consider a transaction done, completed, or valid. Just keep in mind that this is not true for all the data that a financial services institution handles. It's only for core banking data. So they have also asynchronous replication that is good enough for other types of data. But for core banking data, like transactions in a ledger, they need to do synchronous replication, and for that, the IOWN Global Forum, we have a use case. So what is the idea? The idea is that you need to be able to send, again, as I said, data to another data center before a transaction is done. That means that if it takes a while, that the delay is super important, because if it takes a while for me to send something to a data center and get the acknowledgement back, it means that the transaction is delayed until that happens. So what we do with the IOWN Global Forum and the APN is to connect them using an optical switch network, which is offering much lower delay and higher transmission capacity and all that. What is interesting here is that, again, going back to how we develop use cases, we went to London, which was basically the financial capital in Europe. We could consider them like that, and met with many banks. So at the end of the day, the reason why they love this approach is not simply because the delay is lower and they could transmit things more quickly or predictable. It's because they can actually have data centers. They are much more further away physically. That gives them access to less expensive real estate. So if you think central London, anything in a radius of like, 20, 30 kilometers is really expensive. If you can go beyond that, to let's say, 70, 100 kilometers, even beyond, then you are basically accessing much more cheaper real estate, other data centers, and also when it comes to sustainability, I will cover that later, these data centers, they can be located with renewable energy sources. So that's the first use case we've been focusing on. But as you see, this is about always disaggregating functions and distributing. The remote media production for a broadcast company, the industry, this is about basically when you are doing media production. Usually what you do is to send like a physical truck or a crew that is on site, and they need to do the production, because basically you cannot be sending all the information you need, maybe a lot of video feeds, to a central location where you could do the centralized production for many events. With an APN, you can suddenly do that. So you don't need actually to have this crew on site and to have the trucks and everything. You can basically send everything to a centralized location. So as you can see, it's interesting to see how being able to disaggregate functionality from a let's say, functional perspective with an APN sometimes leads to decentralization, which was the previous use case, where you are basically decentralizing data centers and keep them far off, while in other cases, like this use case, it leads to centralization. So you are able to centralize all the basically production, the remote production, into a central location. That's why I said before that just having the APN is not enough. You need to actually study a particular use case to understand how to best take advantage of the properties that Ralph was describing, that the fiber optics they will be providing you with. So I think these two use cases, they illustrate that point very well. If we go to the next one, which, it was discussed this morning also, the remote GPUs, when you have basically disaggregated where the data is and where the compute happens. So the problem is that if you are training, for example, an LLM, you would need to transfer all your data to the center where you are basically doing the compute. And that has also privacy implications. And of course, it takes a long time because these LLMs, they consume a massive amount of data when it comes to training. What we can do here is basically do transfers in real time because we get massive transmission capacity, and actually it's fast enough so that you can usually send these things. It's also important because training usually is a very synchronous process, and the fact that the APN is giving you low jitter and deterministic properties is actually very useful also for them to assume how to distribute that. So this is, of course, top of mind for everyone, the AI, so that's another use case we were working on. And then lastly, the remote construction infrastructure management. This is the last early adoption use case I will be covering. This is about removing human beings from a dangerous site. For example, it could be a mine that it could be dangerous for humans, so you have everything remotely controlled. This is about also sending 3D models of the whole structure of the site, let's say a mine or whatever you have there. So you need a massive amount of capacity to send it. Sometimes we've seen examples where instead of hours, it will take seconds, also to Ralph's point before. So this is also very, very helpful. And lastly, this is also about sensing, where you have basically fibers embedded in the infrastructure, and you can actually do a preventive fault tolerance. You need to do management. So that's actually quite interesting as well. Those are the 4 early adoption use cases I wanted to cover. And as I promised, I wanted to just give you a flavor of what could be one of the future-looking use cases we are working on. In this case, I chose the digital twin framework. And this is about digital twins. So again, this is about having a virtual representation of the network. And the previous speakers, they already discussed that, so that you can manage the network. More importantly, you can prevent failures because you can simulate things and you can see basically when something could go wrong and preventively address that. And it's actually extremely important for handling APNs and this type of network. So again, this is a very good example of ancillary technology that basically supports the APN and deployment in basically real life to manage and do fault prevention. With that, I think it should be more clear to you what the IOWN Global Forum is actually working on. These are actual examples of use cases. Each of them is in different stages, but with some of them we are finishing the proof of concept, proof of value, and proof of business process that I mentioned before. So you will see publications very shortly on them. And then some of them, they will be basically ready for commercial deployment. That, as I always say, that's basically the end and goal of the forum. And with that, I think we could give the floor back to Vito and go into the panel. Thank you very much.
Thank you, Gonzalo. Yeah, if the panel can start coming up, and I'm going to just say a few words, but panel, please come on up and take a seat, and then I'll turn it over to Jeff. I just wanted to mention that I didn't, you might have seen it there as the slides were going by. The IOWN Global Forum is quite active in terms of doing events and being in the public eye. Of course, being here, Mobile World Congress, we'll be at OFC in a couple weeks. And I also wanted to mention the IOWN Global Forum member conference in Australia in mid-April. And it is a member conference, so if you join as a member or you have members in the area or near the area or want to go to Australia, we'll be there in mid-April. But we'll also have an open forum called Futures, where you can attend as a non-member to learn more about what we're doing. And at that event, it's usually 200 to 300 people. So it's a great networking event for you to meet all the IOWN Global Forum members and also learn more about what we're doing. So with that, I won't delay any more, and I'll turn it over to Jeff, and he can introduce the panel. Thank you, Jeff.
Thank you so much.
Let's give a hand to the panel, please.
Wonderful. Thank you so much, IOWN, for having us. I mean, what an incredible topic this is. So this is really about the AI infrastructure shift that's happening and how are we going to capitalize on a decentralized cloud economy. So maybe the first thing we'll do is introduce the panel and have them kind of say a little bit about their position, the company they're in, and then I'll kind of give a grounding statement on kind of where we are. So maybe Derek, why don't we start on this side?
Sure. Thanks, Jeff. So my name's Derek Buckley. So I lead telco, media, and gaming industries for Microsoft in Asia. Essentially, that means I'm there to kind of set the strategy in the field, and then secondly, I'm there to work with our most strategic customers in the region.
Great. Thank you. And Kawashima-san?
Hi, my name is Masa Kawashima. I work for NTT, and my role at NTT is IOWN Technology Director. So my role is to develop a strategy to fill the gap between IOWN's technology advantages and the IOWN's business values.
Thank you. Ralph?
Ralph Rodchat. I'm the VP of Global Sales Engineering at Ciena. And we work with customers all around the world to build out networks, so whether it's service providers or hyperscalers. And in a lot of cases, we're working with service providers to explain to them what the hyperscalers are doing, what's happening with AI, what are the implications of AI in terms of what's happening, growth of capacity. The example I gave you of the hundreds of fiber pairs that can be lit up between a data center, those kind of things are sometimes a little bit out of the grasp of what a typical service provider would want to see. And so we try to bridge the gap and help people understand what's actually going on.
Great. And João?
Thank you for having me. Good afternoon. My name is João Gomes. I work at NVIDIA, and I basically work with telcos that are becoming providers of AI infrastructure, sovereign AI, so their countries can have a strategic autonomy around AI. So that's what I do. Looking forward for this conversation.
Great. Thank you, panel. So myself, Jeff Wang, I'm with Accenture. I'm our Chief Strategy Officer for our cloud business. And why this is such an interesting topic is that we're seeing the explosion of AI. We're seeing the actual requirements to have these data centers be close to population centers, but we're seeing these constraints that are happening around real estate that's expensive. Is there enough water to do cooling? What types of energy constraints are happening to that? And I think that when we look at this decentralized model, this discussion that we'll have is going to kind of bring a lot of optionality to that, which is really important. I think maybe the first thing we do is maybe start with Derek. Like when we look at that AI demand reshaping where compute is, the need for how that consumption is changing, from a hyperscaler point of view, what changes are happening in AI to be driving this decentralization?
Yeah, thanks, Jeff. So I think from my perspective, there's kind of three kind of shifts which are happening. The first being kind of inferencing, kind of moving to be more kind of local and real time. The second piece is data gravity. And the kind of last piece then is AI becoming more core to how you run your business. So in terms of inferencing, so, I think we all kind of understand that training the models is kind of very suited to hyperscale type regions and centralized, both from an economic perspective, and it absolutely benefits from scale. But if we kind of look at how our customers are evolving, essentially what we're seeing is that the need to bring compute closer to the data. We all know the challenges of doing that the other way around. And then lastly, I think if you look at AI, it's no longer a chatbot. It's embedded into business processes. It's going to be a control plane of how we run our business moving forward. There's sovereign requirements. There's compliance. It's going to become so core that we need a decentralized model to be able to support that.
Yeah, it's really good points, especially on kind of the sovereign piece that geographically we're seeing a lot of that come up stronger depending upon kind of where you are in the world on how important sovereign is. And that goes end to end, right? The authentication to the compute, to the data storage, to those pieces. I think next, if we think about kind of, we've heard the hyperscaler point of view, Kawashima-san, when you look at it from an operator's point of view, you heard the word sovereign. We see neoclouds exploding. We're starting to see more of the private networks. What's changing these traditional architectures, and what are the current limitations of where optical networks are falling down today?
So I think with the emergence of neocloud and sovereign cloud, the cloud landscape is increasingly diverse, and we would require the interconnection of heterogeneous clouds with high bandwidth and low latency connections to support, for example, data retrieval and also the collective AI inferencing. But with today's network architecture, creating peering connections or adding peering bandwidth is heavily labor intensive because we have to create physical fiber cross-connect for every 400 gigabits per sec link. And this is because optical transport networks are operated in organizational silos. So we have to interconnect different organization networks at packet layer. So this is why we are promoting IOWN Global Forum Open APN, which is to interconnect different organization networks at optical layer. But this requires ensuring multi-vendor interoperability at the optical layer, and this is where our community work is needed.
Yeah, it's a good point. As we kind of move some of this to the optical layer, what are the differences that are happening? I guess, Ralph, from a technology evolution perspective, when you look at this, and in your keynote you address some of this stuff, but when you look at the APN architecture, how is it different from that traditional optical architecture that's happening?
Yeah. I mean, what Kawashima-san said is absolutely true, and you know, the one way that I think of it is kind of you know, and traditionally we talked about subrate, and APNs are really the death of subrate services. So when I say a subrate service, this is something that's a lower speed service that gets connected into an optical service. So in the past, we would have signals as low as 1.5 megabits per second, you know, a typical T1 or E1 traditional telco kind of service, right? And as the demand for higher and higher capacity services grew, eventually we reached the point where a single wavelength is the unit of consumption. And so what that means is that you start seeing a network where an optical connection from one point to another makes total sense. And that was the vision of the APN, was to have the all-photonic network, to not have any intermediate points. Over the years, that subrate service evolved from traditional electrical services to SONET, SDH, to OTN. These are historical kind of transitions that happen. And now we're even gone beyond that, where we talk about spectrum as a service. So not just a single wavelength, but a grouping of wavelengths that are passing through a fiber becomes a service that can be consumed by two endpoints. And that's really what's driving this adoption of the APN. And as Kawashima-san said, now that you reach that point, the traditional interconnect points, like what used to be an electrical patch panel at a telco location is now just an optical cross connect. And there's no need to bring that down to an OEO or to convert it back to an electrical signal. You can just pass through that location. A lot of that happened in the submarine space, and now it's really happening across the terrestrial markets where, like I said, the unit of consumption has emerged as basically a wavelength or spectrum, or even an entire fiber pair for some of the hyperscalers that are looking for a really massive amount of capacity.
Yeah, I mean, I'd love to hear from everybody on this, but like when we looked at those advantages of speed, when we looked at those advantages of power consumption, we looked at those advantages of cost, but I mean, does it really just come down to that architecture where you're taking out the inefficiency of the electricity on the conversions, then you're basically not having to upgrade everything? I mean, where are the kind of the benefits of this architecture?
Yeah, I mean, obviously the power is something, going down to an electrical level, increases the amount of power consumption, but you would never do that for terabits or petabits of capacity. You would never go down to an electrical level just because it's too consuming. Now, the question becomes at the intermediate sites, when you start going longer distances, you can achieve some really high efficiencies by what we call a hyperrail. A hyperrail is combining a number of fiber pairs, the repeater systems into a very condensed system. And that also faces, because it's not just the power, but it's also the space that's available at these sites, right? You hit the wall, right? You hit the wall, you can't build out any more racks. You hit the top of your power, you can't build out any more capacity. You can't get to that, the one megawatt rack for a GPU cluster, right? So there's all of those limitations cause everything to be every last ounce counts, right? So that's where the APN really starts to kick in.
Yeah, it's interesting. When Joao, when you kind of hear the topics that went on, right? I mean, Derek talking about AI and compute needing to move closer where the data gravity is. Kawashima-san talking about kind of the architecture advantages, and Ralph talking about kind of how we think about these trends. What do you see the changes to the network bandwidth, the latency, the determinism?
Yeah, I think that's a great question. Maybe to comment on that, I would just like to emphasize the importance of network for AI. And if you think about it, back in 2020, when AI was still starting, at least the LLM generation and transformers generation, NVIDIA made an acquisition of Mellanox. And back then, 2020, or 6 years ago, it's quite some time ago, everybody was scratching their head, wow, why, right? Like, is it because of the NICs, or what is the strategic intent? And back then, Jensen used to say, data center is the compute. Data center is the compute, and that was a quote that we repeated multiple times. And everybody was trying to understand what that meant, right, or that meant. And it was really about that AI systems. It's not really compute. It's not really the server that matters, right? It's the combination of compute, the servers, with the network, with the storage, and everything else. It's really the whole data centers. And this is pretty much how AI systems have evolved, right? Today, we have AI factories. That's how we call it. It's highly optimized AI-centric infrastructure. And network is perhaps the most critical part of it, right? And we think about networks, it starts with scale up, right? NVLink technology. How do you group GPUs inside a server at ultra high speed, right? NVLink is 1.6 terabits per second speed, and the fifth generation that we have now. That's like building scale up systems, but like servers that have multiple GPUs that behaves as one. But even that was not enough. Then we start to scale out in the data center and create InfiniBand fabrics or spectrum-based Ethernet fabrics, right? And every GPU talks to every other GPU at 800 gigabits per second in a non-blocking way, right? So you see the amount of networking and the importance of network when you're doing these large training jobs and enabling different types of parallelism and tensor and data and all sorts of techniques to make that possible. And network was the central piece and is the central piece. But the evolution doesn't stop, right? So like a few years ago, the main workload when you think about AI was training. And this is still training. Training is very important, but everybody was creating foundational model, creating these killer applications that we see now that everybody uses. And these massive AI factories with scale out, scale up networks, really, they were built. But now we moved, right? Now AI adoption has exploded. We all use AI every day. Enterprises are using AI. There is a massive demand for tokens. So the workload shift from training to inference, or inferences in addition to training. And the network continues to evolve to support that, right? Inference is also very network heavy. If you think about, dense models like Llama, 400 plus billion parameters, or even a sparse model, mixture of expert model like DeepSeek, it needs very high fabric because you have all this information being exchanged by shards or parallels processing units. And what's starting to happen as part of the inference evolution is we are trying to optimize it as much as we can, right? Tokens per watt is really what matters. And inference is starting to get disaggregated, right? Like we look at the inference process and there is multiple sub-process there. There is what we call prefill and what we call decode, and they have different characteristics. And all of a sudden, as we optimize this, wait a minute, there is a scale across network, not only scale up, scale out. There might be a scale across because you want to build these architectures that really drives down the cost per token, right? And then network again comes like to save the day and becomes extremely important. Today, even disaggregated inference is maybe for large model restricted in a cluster in a data centers because you still have the 800 gigabits per second requirements and this information exchange. But with wavelengths and spectrum as a service, this starts to become feasible in APN networks. So I think this is where things are kind of evolving every day, right? And we shall see how this is going to be, but it's fascinating, I think. And
yeah, I think those three terms, you kind of heard it in the keynote before on how are we going to actually scale up, scale out, and scale across. And that, that word scale, Derek, is incredibly important, right? Because we look at, how does an APN at scale now affect those things like the partner ecosystem? How do we think about the infrastructure location? How do we think about the data moves? How do you kind of see those changes?
So I think it becomes a very kind of different engagement which needs to happen between traditional kind of partners. I think if you look across hyperscalers, telcos, software development companies, hardware vendors, it needs to move to a model that's more co-creation. And what I mean around co-creation is joint software development, joint roadmaps, being jointly accountable for outcomes because the reliance on each of the vendors each of the partners on each other. So I think that shift is going to have to happen. It's not an easy shift because some of those relationships currently are more aligned to a traditional kind of vendor relationship. But moving forward, in order to hit those outcomes, we're going to have to evolve. I think the second part then really is around data movement. I think data movement is going to have to become, it needs to be necessary, really, really necessary to justify. And I think we'll get to a stage where we only move it when it's 100% necessary. So I see infrastructure kind of moving to the workload and us being more kind of focused on the workload rather than the org chart in terms of where we place infrastructure.
Yeah, by the way, so we often talk scale out, scale across, but what Derek says is that it's not just about scale.
Yeah.
More important is reach out, how the computing infrastructure can reach out to enterprise environment where the enterprise data exists.
Yeah. I think when you look at that, Kawashima-san, when you reach out, there's a cost associated to it
Yes,
when
yes,
you're trying to access this. How do you think about kind of, there's always been the previous examples of like, what's the total cost of ownership? It should be going down. How do you think about that in this frame?
So I think I'd like to explain the APN's economic advantages, which I call APN economics. So thanks to the effort of optical engineers, the data rate of the highest transceivers doubles every 2 to 3 years. But it forces network operators to upgrade intermediate infrastructure nodes every 2 to 3 years to keep up with such transceiver standards. Not only is this a heavy financial burden on network service providers, but also it is against the global sustainability. But this is...
You mean e-waste, right? You're creating more e-waste, you're creating more...
Yes. Of course, we keep replacing packet switches and transceiver and so on. So, on the other hand, IOWN APN makes the intermediate infrastructure nodes all-photonics. So that means we can keep using the same nodes across transceiver standards. So, of course, this is good for global sustainability, and also it can reduce the network operators' capital expenditure, and that would enable network operators to provide high bandwidth, low latency connections much more economically.
But that topic of e-waste, right? Like, what about all the transponders, the DWDHs? Like, what happens in that scenario?
DWDM transponders would be purchased by customers. So network operators do not have to waste such transponders, but it has to be purchased by customers.
Yeah, and small part of the bigger...
Yes,
right?
And I think many people would ask that, well, then that would mean that the customers have to pay for such expensive DWDM transceivers. But this is the business innovation of IOWN APN. Well, if DWDM transceiver account for a major fraction of infrastructure providers' cost, but if we move DWDM transceivers to customers' environment, for example, I expect that the typical customers of APN are those who would like to build real estate assets, such as data centers or office buildings. So from the customer's balance sheet perspectives, DWDM transceivers is just a small fraction of their total assets. And adding such DWDM transceivers would significantly raise the value of their assets. So this is the business model innovation that OpenAPN can create.
Yeah, that's a total change in the model from that perspective, right? Good. Okay, so I think just a couple things, right? Like, I think one, going to give the audience an opportunity to ask questions. So please think about what questions you may want to ask. And I think for the panel, we'll have probably one more lightning round at the end of like one final statement. But before we do that, Ralph, we do see an increase in private fiber networks, and these private fiber networks potentially benefit hyperscalers like Derek. But when you look at the performance over distance, what are you seeing between kind of these private fiber networks versus an all-photonic?
Yeah, I mean, it comes back to what I said about the unit of consumption, right? The unit of consumption has grown. And so it used to be an electrical service, then it was, now we've come to the point where a wavelength is the unit of consumption, then spectrum, which is, part of a fiber, and then a full fiber. So hyperscalers will consume a full fiber. They'll consume a full conduit in many cases. So a conduit full of fiber pairs. And that consumption model is driving an extreme demand for efficiency, because when you start having that kind of coexistence, like multiple, the fiber itself that's put in the ground isn't necessarily the bottleneck anymore. It may be the site where you have to put the repeater. So those amplifier huts become the constrictive point. They become the bottleneck where you are limited in how many fiber pairs you can actually light up. So that sort of demand for fiber pairs is driving new architectures. It's what we call hyperrail. And that term refers to an efficiency on power and space that is taking it to the next level. The absolute focus on what we call spectral efficiency, so using the fiber to the maximum, squeezing every last drop of capacity out of it, and even looking at other fiber types like hollow core fiber, where you can launch at higher power, get lower latency, further distances. So it's driving a lot of innovation, a lot of research work in that area, and part of it is also that the service providers have to deal with that multi-generational aspect. The reality is that telcos still have to deal with, as much as I dramatically say the death of subrate. Those subrate services are going to exist for years.
Yeah.
And the same thing, your question about e-waste. I think this is one of the really impressive things about photonic systems, is that they are multi-generational.
Right.
When we lay down a rail, when we lay down a photonic system, the same thing with submarine cables. We have submarine cables that are over 20 years old. They were put in the water and have taken multiple generations of transponders on the endpoints. And at every generation have squeezed more capacity out of that asset that probably cost $500 million to put in the water, right? So that sort of reuse of the photonic infrastructure is built into the APN. It's something that's really a fundamental part of the All-Photonic network, is leveraging whatever you have in the ground, because whatever you put in the ground is expensive.
That's a great point. Maybe Kawashima-san, you can kind of talk through that, because I think that people may not kind of fully capture that there's overbuilt fiber already out there, and there's glass in the ground today, and it shouldn't be the fact that you have to redig everything back up and then relay this. So, can you talk through kind of ways that you can solve this every few pieces of distance? Like, how could you solve with existing glass in the ground?
So basically, fibers are multi-generational. But the issue with today's network is we relay packet information with packet routers or switches.
Yep.
And this component is not multi-generational.
Right.
So having optical switch, replacing such packet switches with optical components would make the end-to-end infrastructure multi-generational. That's the point.
Yeah.
And I believe that any infrastructure should be multi-generational. For example, let's think about cars. Cars evolve, but we don't have to replace highways for each generation of cars. That makes the infrastructure very effective. So, but up to now, the telecom networks is not built like that. But IOWN APN will make the infrastructure, will make the telecom infrastructure multi-generational.
Yeah, that's an interesting, almost future-proof example of kind of how to do this. So we started the conversation with, hey, AI is exploding, we're requiring data centers. How do we think about this when there's constraints on these current data centers? So Joao, when we're seeing not enough power, not enough water, not enough real estate that Ralph had talked about and Derek had talked about, what do you see as challenges if we go to distributed data centers, if we go to smaller data centers, if we talk about scaling across, what are some challenges you're seeing with connecting these?
Yeah. Well, I think we all highlighted this. I think we're shifting from training to inference because of utilization. And honestly, I think we're at very early days, right? Probably most of us here are using AI assistants every day now, but it still has a long way for this to become more pervasive, and eventually it will be. So there is this race, right? These tokens, they are generated by a new infrastructure that is not yet in place, right? It does not exist to the scale that is required. So we see every day, I think, reports even from your company analyzing the amount of LPS, land, power, shell, right? The substrate that is needed to build these data centers. And then if we correlate this with the demand and the way this technology is evolving, there is a gap, right? In some regions, the gap is more significant than in others, but generally there is a gap. There is a new infrastructure that needs to be in place. And I think that's where this concept of distributed infrastructure comes in place. And you know, like when build new data centers, people talk about land power shell, right? LPS, that's all people talk about. They often forget the connectivity aspect, right? So they identify new sites and see power. Obviously, this needs to be connected. But the gap created potentially a new opportunity because in many cases, telcos, they scratch their head, they've been optimizing their data centers, right? Like the telcos have data centers everywhere, distributed data centers, edge data centers, and it used to be very heavy, right? All the equipments, the pots, the copper, everything. And it has been optimized for years and years and years, and it's underutilized. These data centers today are mostly underutilized, and there is stranded power in most of them. There is stranded power that could be power from the grid that could be used for something else. And I think this is what we are starting to see, this idea of, well, there might be a distributed infrastructure, right, that is going to provide tokens for applications. And because telcos have all these distributed sites and they are all fiber connected, right? So that becomes an opportunity. And we are seeing several telcos already realizing that opportunity or like starting to work on that opportunity and figuring out ways to move forward. And in terms of requirements, I think we discussed, I touched on some of these points earlier, right? I think the way inference is evolving, right? And this aggregated serving and things of that nature, it creates this need for pretty much like very dense networking between these sites, depending on the architecture you choose. And I think this can be a game changer for our industry, for the telco space and networking, and it just highlights how network has always been important for AI, and that is just going to increase as we move along.
Yeah, that's great points. So I think now, before we're gonna ask kind of each of the panelists what one thing that they suggest to get involved, let's ask the audience any questions or any things you want clarified or anything you're curious about around this. Who has some questions? You guys have done such a good job that you've answered an incredibly complex topic in a very clear manner. Okay, you've done it. Okay. Oh, yes, okay. Please. You can, I'll repeat it. You go ahead. Yeah, compare. Yeah, so the question for the audience is, thank you so much. If you had a comparison between the traditional centralized model versus a decentralized model, what's the percent improvement or delta gap that you could see? So panelists, what do you guys think? Thank you for the question.
Maybe I'd go first. Of course, for large-scale training, if we can assume that the data can be centralized in a single place, probably, of course, the centralized computing infrastructure would make sense. But in many cases where we cannot collect data, for example, the enterprises would not want to upload their data to the centralized place. For such cases, probably they're distributing the data centers and let these distributed data centers interact would make more sense. So it depends on the workload. And typically for fine-tuning, we need to make a computing infrastructure that can be closely integrated with an enterprise environment. For such workload, probably a distributed inferencing would make sense. And also, not only for inferencing, but not only for fine-tuning. Another case where the distributed computing infrastructure makes sense is inferencing. Because for inferencing, we need a computing infrastructure distributed closer to point of service, which may be outside the enterprise campus. And also, for such use cases, distributed infrastructure would make sense. So it depends on the type of AI workload.
I think that's the important thing to note. Like, I used to build devices, and we always had different types of processors for different type of workloads, and that was important to think through. That the current generation of where we're at, we're doing a lot of large language model training, and it requires a centralized location to do that, as you had mentioned, Kawashima-san. As we evolve where AI is going, we'll start to see small language models, we'll start to see inferencing at the edge, we'll start to see these changes in requirements. And in which case, just like on the device, we had big little architectures where we had kind of big processors doing kind of the heavy lifting, and then we had smaller processors doing kind of the more specialized things. And I think it's a very similar analogy, it's an analog to what you described, that there's moments where we'll need, right now, you need to think about centralized for efficiency, but very soon, we're going to get to this distributed architecture where it's much more efficient to run them in smaller data centers. And if you need more capacity, you scale across.
Yeah, and that one thing I touched on in my presentation around scale across is the absolute importance of reliability.
Yeah.
Because the training itself it's very compute intensive, and if you have a failure of that as a result of a loss condition or a flap occurring, then that causes the training to restart, and you've lost that energy. That energy that was taken to start that training and get it to that point is wasted. So, we see that demand for very high reliability, in particular for the scale across type of application. Like I said, we're lighting up hundreds of fiber pairs with, thousands of interfaces, and the reliability becomes so important. So that kicks back into, how do you make sure that you're not wasting energy when you're doing these training, right? Because that's really the big thing. When we get into inference, again, that's something we're all looking at, and we're trying to see what will the impact be, especially for service providers, because that inference will then drive capacity back into the metro networks and different, more of a distributed type of capacity. We're sort of watching that to see how that will happen, and these panels are a great place to learn more about how that's being observed in different spaces.
Yeah, I think just to add, I think the other important aspect on this centralized versus distributed is obviously the user experience. The user experience is something that is also evolving very quickly on AI, because if you think about AI and chatbots and the way this is started, it doesn't really matter if you get your answer in a few seconds, or is it still like a human interaction there? It's okay. And if you go back a few years, if you think about user experience and latency, right? Like there are different factors, but in an oversimplified way, you have like compute latency, and then you have the other latency, including network latency. And at the early days, it was so much like compute latency was so much higher than the network latency that, it didn't really matter. You can optimize the network, but the other is so order of magnitudes higher than the network latency that it didn't matter. But that has changed now, right? And someone mentioned SLMs and multiple techniques that is really making real-time AI and enabling all sorts of use cases. And that is also going to change and accelerate this shift, right? Or this complementary aspect between centralized and distributed. And I think we're all learning and seeing where this is going, and it's just fascinating.
I love the question. I think it's a good push for all of us involved, that how do we quantify the difference on a centralized computer versus decentralized. So I think we're starting to quantify the TCO, and I think that's a good push to actually quantify that number. So thank you. I love that question.
But I also think we need to look at it in another way, right? If we look at it at the enterprise angle, at the moment, what's stopping enterprises moving their environments to more kind of efficient cloud type environments is the centralized model. The decentralized model means they can get a lot more scale, leverage, performance out of their current assets, right? So to me, if we go towards the decentralized model, it will enable more enterprises to migrate to cloud. They're then going to gain efficiencies from that.
That's a clever way to look at it. Okay, so panelists, lightning round. What is one thing or piece of advice you could give to the audience on how to get involved? Who wants to start? I can start. I wore IOWN socks.
Yeah.
So
matching.
Okay.
There we go. Yeah.
Matching socks.
Different generation, multi-generation.
Multi-generational socks. Yeah. So that way, the black and the blue version, I think that's one way we can start to. Yeah. But I do think we can drive some of the awareness of this. Yeah. Right. The first biggest part is like the awareness of how do we actually find the advantages of this, because this is coming. There honestly isn't an answer where the current generation of networks can handle what's happening in terms of compute, storage, and network that's required.
Well, lightning round, get involved, come to OFC. OFC is for us very important, optical.
Yep.
We'll have the IOWN multi-vendor, multi-layer demonstration. So that's a good place to come have a look and drill in and ask more questions about how you can deploy APNs. So that's a great start, I think.
Ralph, love that. March 17th to March 19th, my hometown, Los Angeles, California, at the Convention Center. Please join us because we will be there for IOWN Global Forum. What else?
I'd like to say again that scale is not about everything. And in future, reachability and connectivity would be more important for AI computing infrastructure. And this is why the OCP and IOWN Global Forum has launched a new initiative titled AI Computing Continuum. Yep. And this means that it's not just hyperscalers or neoclouds that build AI computing infrastructure. All of you will join in the creation of the new next generation's AI computing infrastructure. So please consider how you can make your workplace more smart with AI by connecting your facilities with APN. And bring your ideas to IOWN Global Forum meetings.
Yeah. Thank you, Coach. Yes.
Yeah, maybe I can go next. I think, like, if you think about the future and all of this, I think we all here, we have the privilege to be in the middle of this foundational shift, right? There is this new technology and there is new infrastructure and there is pretty much new everything that is going to be built for this new paradigm. And I think collaboration is the most important part of all of this, like we are here in APN and everything that we do together to understand, because these are all new challenges. These are things to be invented, things to be created. So approaching this with this creator mindset and open mindset, and I think this is how we're going to make this incredible, and super excited to be living and have the privilege to be experiencing this.
Yeah, I think if you were here before, Chris kind of said it right. This isn't a moment to be on the sidelines, right? We have to get involved now. We have to be able to build, iterate, scale now, and work together. And I think collaboration is a really good point around that. Derek, you...
Yeah, so I'll kind of, again, look at it more from the customer or the enterprise angle. And, what I can see evolving is similar to my talk track earlier. This isn't about chatbots. This is about evolution and infusing AI into business processes. It's about changing the way we run every business around the world. This is a supporting foundation for that. But I can tell you now from conversations with customers, this is going to come so fast, right? And as we look to transform our own companies that we operate in or our own enterprises, this is a fundamental requirement to enable that.
Yeah, I think that's such an important point. Like if you believe the thesis that AI is the next gold rush, easy thesis to believe in, then the pickaxe to that story is an optical layer. That pickaxe where you can't go wrong is to get involved in this value chain at this point. That's the safest and most important position to get involved in. So first off, big round of applause for our panelists. Thank you so much for spending time with us.